Today we're going to go over minimum, maximums, and zeros of polynomial functions. We're just going to be identifying them and approximating the points at which they occur. We won't be solving. That's for a later section. So there are two types of maximum and minimums. We have local, okay, and these occur between the endpoints of the function. Or the ends of the function. You know, if it's a continuous function, it's not necessarily going to have a point for that. And these occur when you have continuous functions. If a function is not continuous, it will just have what are your absolute maximum or minimums. Okay, and these are your highest and lowest points on the function or on the graph. Now, if you have a continuous function, like we do here on the right, if you look on the left-hand side, you'll see that it continues in the negative direction down here at the bottom. And on the right-hand side, it also continues down in the negative direction. So when they're continuous, you're not actually going to have either a minimum or maximum depending on which way it's going. You won't have an absolute minimum or maximum because it will just keep going in the infinite direction, whichever way that it's going. But if we look at what we have here, we're going to look at the local minimums and maximums first. We can identify these from left to right. I'm just going to give it to you. You know, your maximums occur at your peaks, so your highest points, and your minimums occur in your valleys, so your low points. So if we look here at this continuous function, we have, you know, 5 maximum and minimums here. Well, 3 local maxes and 2 local minimums. Sometimes, depending on your function, like if your endpoints are going to go in the same direction, or your end values over here, the ends of the function, you know, since these are both going in the negative direction, you will have one absolute maximum, and that'll occur at whatever the y value is for that maximum point. When we're talking about maximum and minimums, we're talking about the range of the function or the y values. So that's really all we care about. If we go through here and approximate the values of these, you know, and I'm just assuming that these hash marks here on the graph are going to go by 1. So I'm going to go from left to right. So this point over here is probably going to be 1, 2, 3, 4, -5, you know, and 2.75. And I'm just approximating. I'm not going to take points off on your homework if your answers aren't exact. This local minimum, this next local minimum over here is going to be at about -1.75 and -2. The next max is going to be at approximately 1 and 1.75. The next minimum is going to be at 1, 2, 3, 4, you know, maybe 5. -1, 2, 3, 4, 5, 6. Okay, we can see that's -6. And then the last one is going to be over here at 5, 6, 7, you know, 8. And 1, 2, you know, 3.5 maybe. So when we're talking about the maximum and minimums, remember we only care about the y values here. So we could identify these as our local maximum. Now, if we want to find our absolute maximum, we're going to look at these points and see what our largest value for y is. And that's going to be over here on the right-hand side, this 8 and 3.5. So we're going to have an absolute maximum, and you can abbreviate it ABS if you want to, at the point 8, 3.5. And if we're talking about our absolute minimum, you know, we're not really going to have one because it continues in the negative direction on both sides. So it's just going to be negative infinity, or, you know, none, but negative infinity. And then you would just list the other 4 as your local max and mins. Okay, and that's all you're going to be doing on the homework, just identifying them and approximating the values. So if we look at these functions here, we can approximate the local maximum and minimums and the absolute. So I like to just go from left to right. If we look at this function on the left-hand side over here, it's continuing in the negative infinity direction. So we're going to know that our absolute minimum is going to occur there. And it's just going to be negative infinity because it's going in the negative infinity direction. As we come up, we have a local maximum right here. And that's going to be at approximately, I don't know, negative 1.25 and, 0.1. We have a minimum right here at this valley, and that's going to be at negative 0.75 and negative 0.1. If you come over here, the next minimum, or excuse me, the next local max, this was a local minimum, and this is going to be a local max, it's going to be at 0.75 and 2.1. And then we have a minimum here, and that's going to be at 1.25 and I don't know, 1.95. If you put 2, I'm not going to take points off. And then it continues on in the positive direction here. Okay, so our absolute maximum is going to be here at, infinity. If we look at this function here at the right, it's a cubic function, it's to the third power. If we look on the left-hand side here, you can see that it's continuing in the negative direction. So that's going to be your absolute minimum. If we follow the function up, we see a maximum here, a local maximum at 0 and 7. Follow the function, we have a local minimum over here at 3 and negative 2.25. And then it continues in the positive direction over here. So that's going to be your absolute max at positive infinity. And that's all you're doing for maximum and minimums on the homework. I also want to go over zeros of a function. Hopefully these are familiar to you. Zeros are your x-intercepts, so where the function crosses the x-axis. So your x-axis is this one right here, And after going over our x-intercepts that y is always 0 here along this line. So all I want you to do is identify where the zeros occur, or just circle where you're going to find a 0. So we have one here at whatever point that is. That's going to be like negative 8, and 0, whatever that is. This one's going to be a negative 1, 2, 3, 4, negative 4.5, 0. And these are all 0 because they're on the x-axis, and y is 0 there. This one's going to be at like negative 0.75, 0. This one's going to be at, 2, 0. This one is going to be, I don't know, 2, 3, 4, 5, 6, 0. And then if you notice, the picture here kind of cuts off the graph, but if you follow it down, you're going to see that this function continues in the negative direction and that you would have one more 0 over here. And the zeros are important because they kind of help us identify the nature of the function, what it looks like. So the maximum and minimums help us tell, how curvy a function is. If we know that the function's going like this, we don't know what these peaks and maximums are. But if we do know, that helps us approximate, okay, well, what's happening in the function, at what points. And then the zeros kind of tell us where on the graph to put it, or do we need to shift our function more to the left, more to the right? How much time is passing between, these peaks and valleys. So this is why it's important to be able to identify them and, kind of approximate where they're happening. And in one of the later chapters, we'll go ahead and solve them. So if you look at these functions here, you could approximate the zeros if you wanted to. The one on the left here, there would be 1, 0 here, 1, 0 here, and 1, 0 there. this one here on the right, you're also going to have 3 zeros, and you can tell me the values for these points. One thing that you need to know is that sometimes you won't have any zeros. For example, if you had a parabola that was just hanging out over here in the second quadrant with the vertex, right there, this function here, this graph, it's not going to cross the x-axis. So you're not going to have any x-intercepts, and you will have no zeros. Okay, and on your homework you can just write no zeros if there are none. Another thing that you could have is you could have a parabola or a function that only just touches the x-axis, so it looks something like that. In this case, you're going to have 1 0. Okay, and it's going to occur at that point, 5 0. Okay, so you can have no zeros like we do over here on the left. You can have multiple zeros like we do here in the middle on this red function, or you can have 1. So just be aware of the different ways that the function can cross the x-axis. If you have any questions, you can always contact me via Remind. Your homework is up on the website, and if you have any questions, like I said, you can contact me or we can talk about it tomorrow in class.